So our next presentation, user presentation, Shufen's going to talk about the genotyping platform for cranberries. Thank you.
Good morning, everyone. Thank you for the organizer to let me to present our research. So the research, the title is Development and Validation of a Mid-Density Genotyping Platform for Cranberry. So cranberry is gaining global popularity in both production and consumption due to its distinct flavor and potential health advantages. So the United States is the world's leading cranberry producer, followed by Canada, Chile, and others. But the traditional breeding for new cranberry cultivars with such as good productive, disease resistance, fruit quality, desirable trait combinations is mainly where phenotypic selection, which is labor intensive and time consuming. So here we would like to integrate genomic-based techniques so to speed up the breeding process by making selection decision in the early breeding cycles. So this research, the objectives are to create a 3K DAO-tag genotyping panel and to evaluate the usability of the 3K DAO-tag panel in linkage map construction, identity confirmation, and other genetic analysis in cranberry and related vaccinium species. So to create the 3K marker panel, so 53 core breeding lines from white cap SNPs that were used for marker selection. So this marker loci were selected based on math, missing rate, and also the spatial distribution across the genome. So we also included the markers associated with previously identified QTLs. Since they are interested in studying cranberry blueberry hybrids, so we developed 54 cranberry blueberry conceived markers. So as highlighted in red, so this a genomic distribution plot. To validate this 3K marker panel, we used the cultivated diploid diversity panel and wheeled out tetraploid diversity panel to test the performance of this 3K marker panel. So we also used two diploid reciprocal cross F1 populations. So that is can be genotyped for linkage map construction. Also, we use allotetraploid cranberry blueberry interspecific hybrids. So that can be used to test that 54 cranberry blueberry conceived markers. So we check the missing rate first, of marker in each population. So we found that all populations have lower than 35% missing rate. But in this plot, you can see the wheeled diploid diversity panel has higher missing rate than the cultivated diploid diversity panel. But for the two F1 populations, they have a similar missing rates. So PCA using read depth show the clustering of different populations. So from this plot, a diploid diversity diversity panel clustered in the middle, and the under the outer tetraploid diversity panel slightly shifted towards right. The interspecific hybrid samples tightly clustered up, yeah, right. So but for the F1 populations, they are in the bottom left corner. But if we zoom into the two F1 populations, so we can see, so it's very clear. So they are like can be clustered separately. So each, let's say, proco F1 population, cross F1 population can be used for linkage map construction. So we perform the dosage calling for target sleeves in each of 5 validation populations separately. So using Updog package. So after filtering for math and the missing rate, so a total 1,403 markers were returned in a deployed diversity cranberry samples with panel with 201 lines. But if we push a limit of the 3K marker panel to genotype auto-tetraploid diversity cranberry panel, so we can find on the last marker only 788 markers were returned after filtering for math and the missing rate. So you can see the left like figure. So there are less the smaller number of like polymorphic markers identified in auto-tetraploid diversity panel. It was likely due to the less genetic diversity among setting lines. So next, we also like for each of 2 F1 populations, we constructed a linkage map using the MapPoly package. So in this package, the markers and the individuals were removed if meeting the following criteria. The linkage map was constructed using the linkage map with like 12 linkage groups was constructed using 846 sleeves. A total length is around 1,200 centimeter. So the left figure, that is the marker order based on the genetic map. So accurate very well with the order of the physical positions. And the table like summarize the number of markers and the gap information in each linkage map. Also, another linkage map for the other like F1 population also was constructed use a little bit less markers, around 692, but resulted in a similar map length. So these like 2 F1 populations have a common parent. So like 2 maps shared 529 sleeves. Also, each map contains unique sleeves. Yeah, but here I also would like to thank Marcelo, even though like he's not here. Thank you, thanks for his like amazing work to develop MapPoly too, because with the shared parent, we are going to combine these 2 maps to increase like mapping resolution for QTL analysis. So next, to evaluate the 54 cranberry blueberry concept markers, so we genotyped cranberry blueberry hybrids samples. But before we dive into the dosage calling step, so we have no idea whether these markers were like amplified in cranberry subgenome or blueberry subgenome or 4 subgenomes. So first we checked the mean race depth of of these markers in hybrids. So using diploid and auto-tetraploid cranberry samples as the benchmark for comparison. So we can see from those like figures. So we can observe like a similar read depth across like hybrids, diploid and auto-tetraploid cranberry samples. So for example, for this marker, so we can observe the similar mean race count across 3 plots. So then we checked the rate depth, the ratio between the reference alleles and the alternative alleles for each marker to figure out dosage calling pattern among hybrids. Yeah, so we also used the diploid cranberry sample and the ultra-tetraploid cranberry sample as a benchmark. So we found that there 12 concealed markers were amplified in the tetraploid pattern. So in this example, so the purple dose represent diploid cranberry samples, and the red dose represent the ultra-tetraploid cranberry samples. The green dose represent the hybrid samples. So we can say in this we can say in this plot we can saw the 5 clear clusters in hybrids. So that means such marker show the tetraploid behavior. So then we perform the dosage calling for these markers. So we found 5 genotypes were identified. Okay. So we also found some conserved markers were amplified in the diploid pattern, but we have no idea. We are not very clear those polymorphic markers came from cranberry genome or the blueberry genome, because we don't have the blueberry samples as the benchmark. So we also found 74 the concealed markers that were not polymorphic. But I'm not going to show that plot, but we have all plots generated. If you are interested in that, I can show you. Yes. So finally, I would like to conclude my research. So the 3K delta panel can be used to genotype both diploid and tetraploid cranberry lice. So as well as cranberry blueberry hybrids, but have higher missing rates in non-cultivated cranberry samples. Also, linkage map was constructed for 2 F1 populations and can be potentially used for QTL mapping. Concealed markers also can be used for genetic studies in cranberry, blueberry hybrid progenies. So this 3K tag panel is available to the scientific community as an affordable and effective genotyping platform for genomic studies and breeding in cranberry. So finally, I would like to thank Breeding Insight and Cornell University to support this research, and also thanks the USDA to fund this research, and thanks Choose for Polyprice to give us the chance to present this research. Yeah, thank you so much.